Okay, good morning, everybody. So today we're going to continue to discuss Chapter 7, Section 1. And I'm going to briefly give you a little bit of an idea of what would entail if we were to try to solve these systems by hand. If you recall back in 6.3, I did show you a technique called back substitution. But back substitution is very limited because you needed your system to be in what was called row echelon form in order to be able to take that bottom variable and then substitute it in the equation right above that to come up with the second variable, and then you could take both of those and then substitute it in the first one. So we are not going to go into how to solve these by hand very much like I would normally do if this were a regular school year. But I do want to give you a brief idea because you may encounter this course we use a college algebra book, and this is something that you very possibly will learn in college algebra. So what I want to talk about today very briefly is how to use elementary row operations to obtain what is called the identity matrix. Now, this identity matrix, this word right here, identity matrix, is very important because that is going to be what allows us to solve these. And we're actually going to be using our graphing calculator to obtain what is called the identity matrix. So these are the things that you're allowed to do when you have a matrix of, rows and columns of numbers. You're allowed to interchange two equations, which means take the two rows and flip them. So if you want the first one to be where the second one is, that's fine, and you can put the second one where the first one is. You're also allowed to multiply an equation by a number. And then you're allowed to then add that new equation that you got by multiplying to another one and replace. And so it sounds kind of complicated because it really kind of is when you do this by hand. In matrix terminology, these operations correspond to what are called elementary row operations. And so, as I said, I'm not going to go into the actual how you do this. I wanted to just kind of briefly give you an idea of what you're allowed to do. And those are the three things that you're allowed to do. But we're going to be using our graphing calculators to solve these. So, the method or the technique that we follow when we're trying to do those three things is called Gauss-Jordan elimination. And what it ultimately does is it gives us a new matrix, an augmented matrix. So we start with an augmented matrix, but it gives us a new matrix that is what is called the identity matrix. So I'm going to draw the identity matrix down here, and you can see what the identity matrix is it has all ones in it. And then the augmented part, like that, is the actual answers, right? So remember, this is the key thing to remember. This column right here represents x's. So if you only have a 1x right there, that tells you that x is 8, right? So that means x equals 8. Now, the same thing, this column right here represents the y's. So if there's only one y, a number, there's one right there, that tells us that y is 7. And then the last part is this column represents the z variable. And so there's only a 1 right there. And so that tells us that z is 6. So what I want you to see from this, there's two parts to this that I want you to understand. The first part that I want you to understand is this over here, where you have ones on the diagonal and there are zeros everywhere else. That is called the identity matrix. And the identity matrix allows us to see what the x and the y and the z variable actually equal. And so this is what we want to get as an answer. So we put our system into a matrix, and then we're going to make our calculator do the hard work for us, and it will spit out an answer. In this case, x would be 8, y would be 7, and then z would be 6. This Gauss-Jordan elimination that the calculator is going to do for us is actually named for Carl Friedrich Gauss and Wilhelm Jordan. And they invented this, well, not really invented, but they discovered this, over 100 years ago. And it continues until the reduction process, until we obtain what is called reduced row echelon form. And the reason why it's called reduced row echelon form, also known as the identity matrix, but it's because you can see there's no numbers here or here, whereas row echelon form just had that stair step pattern. So reduced row echelon form is a little bit more powerful of a form because we can get our answer right away from it. So that's enough about how to who figured this out and all this. I'm going to actually show you how to do this now. And so it says the TI-83 and the TI-84 graphing calculators can calculate reduced row echelon form of a matrix. And it's actually really pretty simple. The hardest part about calculating this is putting the matrix into your graphing calculator. You have to make sure that you do it correctly, or else you will not get the correct solution. So it says first you must enter the system of linear equations augmented matrix into the calculator. So if I'm looking at this system that I have right here, I'm just going to write the matrix real quick so it make it easy to understand. It's a -3, a 7, a 2, and then we would have this augmented part. Now I'm going to give you FYI, on the graphing calculator, we can't put that augmented in there, okay? So it's just going to be 4 numbers across, -3, 7, 2, 1. Then we're going to have -5, 3, -5, and then -8. And then we're going to have 2, -2, -3, and 15, just like that. Okay, so that is going to be our system. So the first thing that we have to figure out is what is the order of that system? If you remember when I taught you about orders, I said this is important. You're going to have to make sure you understand how to do this. Your calculator needs to know how big of a matrix that you want to enter into it. So you need to know what the order is. Remember, the order are how many rows and then how many columns. 1, 2, 3, 4. There are 4 rows. And there are 1, 2, just did that completely backwards. Excuse me. How many rows? 1, 2, 3 rows, right? There are 3 rows, and there are 4 columns. 3 rows, 4 columns. So this is a 3 by 4. You see, I almost messed it up. It is very easy to mess up. It's how many rows, how many columns. So this is a 3 by 4. So we are going to, and I actually think I'm going to take this down for a second. I was going to show you slides, but I think it's easier to just show you with the graphing calculator how to do this. So my graphing calculator should be popping up here in just a second. And you will see that I got to quit out of there. Okay, so the first button push I'm going to do is actually, you can see there's a button right here called matrix. So I'm going to hit second and then the matrix key, and it brings this up. And we want to enter this matrix into our calculator. So we need to scroll over to edit, and then we'll put it in for matrix A. We'll call this A. And now the first thing that you have to do, as I said, is you have to specify how big of a matrix we're going to put in. So we're going to put a 3 by 4 matrix in there. All right. And so now you can see the calculator automatically generates a 3 by 4. And so I'm going to proceed then to type in all of those numbers from that first problem. So I have a -3, I have a 7, I have a 2, and then I have a 1. And when I hit enter, so we're going across the rows, it takes you automatically to the next row. Then I have -5, 3, -5, and then -8. Oops, I have no idea what just happened. I apologize. We need to go back into matrix and into my edit. Okay, so we have a 3 by 4. We have -3, 7, 2, 1. And then I'm going to keep going here. We'll go into the next one. There is a 3. Nope, there should be a -5. Then there should be a 3. Then there should be a -5. And then a -8. Then the last row is 2, -2, -3, and then 15. Okay, so if you look, you always want to double check all your numbers are in right. So I have -3, 7, 2, 1, -5, 3, -5, -8, and then 2, -2, -3, 15. All right, so now I have my matrix entered into the calculator. So we're going to hit second quit and we're going to go back to the home screen. Okay, I'm going to clear out anything that I have in there so there's no confusion. All right, so now what we want to do is we want to take that matrix that we had and we want to put it in what is called reduced row echelon form. And so the calculator has a command for that. So you're going to hit second matrix again, but we're going to go over to the math command. So you type the right button one time to math, and you're going to scroll all the way to the bottom to where it says RREF. And you see it right there, RREF. That means reduced row echelon form. So we're going to choose that. We're going to press enter. Now what that does is it puts the command in the home screen. It's telling the calculator, find the reduced row echelon form. And now we need to tell it what matrix we want it to find it of. So if you remember, we put our information in for matrix A. So one more time, we're going to hit second matrix. We are going to choose matrix A now, just have to hit enter. And we're going to close the parentheses. So you can see we have RREF matrix A. And then I can hit enter. And when I do that, you can see there is reduced row echelon form. We have the identity matrix over here, the first three columns. And then the right-hand most column is our solution. Okay, so what that tells us, because the 1 is in the first column, that is x. So x is 7, y is 4, and then z is -3. So as I said, you have to enter the data in first, then you tell the calculator to find reduced row echelon form, and it will give you a new matrix that is in reduced row echelon form that has your three answers in the last right-hand most column. And as I said again, the ordered triple, I can't write over this screen because I'm showing you my calculator, but the ordered triple would be a parenthesis, and then it would be 7, comma, 4, comma, -3, and then you would close out your parenthesis. So there you go. It's pretty simple. It's a lot less work using a calculator than it is to do these by hand. So I'm going to end part one right here because announcements are going to start, and I'm going to start part two in a second. Have a great day.